Chapter 1, the Scientific Method and Research Methods. As we recall, the definition of psychology is the study of behavior and mental processes, and the scientific method is how we research the behavior and mental processes. So the goals of the scientific method in psychology are to describe, explain, predict, and control behavior and mental processes. When we begin to do research in psychology, we hold a few assumptions about the process. One of the assumptions that we hold is that events are lawful. In other words, they follow predictable patterns. Events are explainable. In other words, we can seek answers to why things happen. And the final assumption is that psychologists are both open-minded and yet also skeptical in a healthy way. So all of these things add up to the concept of critical thinking. So, with critical thinking, we have key attitudes and mental skills that characterize this process. A critical thinker is flexible, yet maintains an attitude of healthy skepticism. The critical thinker scrutinizes the evidence before drawing any conclusions. The critical thinker can assume other perspectives. They are aware of their own biases and their own assumptions. They are able to engage in reflective thinking and metacognition, which means thinking about how they're thinking. And all of these things are not a single skill, but it is a set of thinking skills. Here's an overview of the steps in the scientific method. First thing we're going to do is we're going to formulate a question that we want to test, and this is put forth in the form of a hypothesis. Hypothesis is a testable question. Second thing is we're going to design the appropriate study to collect the data, and we have two categories of studies. We have experimental studies or descriptive studies, and we'll drill into these two categories a little bit later in this chapter. Next, we're going to analyze the data to arrive at conclusions. We're going to use statistical procedures. We may also use meta-analysis, and what that means is we're going to use meta-analysis when we gather a bunch of individual research studies and see if there's an overall trend or big picture conclusion that we can draw by combining all of those studies. Finally, we're going to report the findings in a peer-reviewed publication. And when we report the findings, they're going to be detailed very specifically so that the study can be replicated. And through replication, that's how we build confidence in the results of the studies. So let's look at some definitions. Empirical evidence. This is evidence that is the result of objective, not subjective observation. It's the result of measurement, and it's also the result of experimentation. The hypothesis is the testable prediction. Here's an example. People with lower self-esteem also score higher on a depression scale. So that is a tentative statement that we can put to the test. Then we test our hypothesis using descriptive or experimental research. We need to identify the variables. We need to operationally define how the variables will be measured. So this is a precise description of that measurement. So for example, if our testable hypothesis is that people who report lower self-esteem also score higher on a depression scale, depression is operationally defined by the score on a Beck depression inventory, for example. And this is a standardized instrument that has been validated to test depression. So this is an example of the APA format of how findings are reported. So this is the APA format for the reference to a publication by Jessica Tracy and Richard Robbins, and it was published in the Journal of Personality and Social Psychology. So when you complete your research paper later in the semester, you're going to report your sources in this format. Now let's look at a theory. A theory, again, is the tentative explanation for observed findings. So going back to my earlier example of people with low self-esteem suffer higher rates of depression, we might find that that's true in our research, or that's supported in our research, okay? But the question is why. So a theory is an attempt to explain why something happens. What I'd like to do is drill into what we mean by a theory, because outside of the scientific community there's a misunderstanding about what a theory actually is. For example, former President Reagan demonstrated this common misunderstanding of the concept of a theory by saying that he was not troubled by the idea of evolution because it was, quote, just a theory, unquote. So the president's statement is the essence of a common myth in society today, that an idea is not worthy of consideration until it is no longer a theory, but it might be considered a law, for example. But I want to point out that theories and laws are very different kinds of knowledge. Laws are generalizations or patterns in nature, while theories are attempts to explain those patterns. So, for example, the law of gravity expresses the relationship of mass and distance to gravitational attraction as described by Sir Isaac Newton. So we all pretty much know this and are confident of that. However, the more difficult, and many would say more interesting, issue with respect to gravity is why this law operates the way it does. And so at this point, there's no well-accepted theory of gravity in the scientific community. Some scientists suggest that gravity waves are the correct explanation, with clear confirmation and a consensus in the scientific community. However, most feel that a theory of gravity still eludes science. So remember, a law is a pattern in nature, and a theory is an attempt to explain it. Now, in psychology, we don't have many laws. However, what we do have are facts, and facts are reliable patterns of human behavior. So, for example, the fact of the matter is that children acquire rules of grammar in the same pattern no matter which country they're born in, no matter which language is their native language. The way children learn language is in a predictable, reliable pattern. So the question is, why is this? Well, that's where the theory comes into play. Noam Chomsky developed a theory that said each individual is born with a part of their brain that he calls the language acquisition device. And this is an attempt to explain why children acquire grammar in the same predictable pattern. So to summarize, facts are patterns of human behavior, laws are patterns in nature, and theories are attempts to explain both laws and facts. So now my question for you is, can a theory ever be proven? The answer is no. So now my question is why? The answer is because we can never control all of the variables. We will always be testing a theory. So a theory, we would say in science, is either supported with each successive study or test, or it is not supported with each successive study or test. We can never say that a theory is proven. So we have two types of research strategies, as I referenced before. Descriptive research. So this is a strategy for simply observing and describing behavior. Second category is experimental research. And this is a strategy for determining or inferring cause and effect between two variables. So descriptive research methods, remember, are strategies for observing and describing behavior. The goal of descriptive research is to answer important questions through either naturalistic observation, case studies, or surveys. And we use correlation as a way to analyze the data that we gathered in these types of studies. The important thing to remember here is that descriptive research never ever tells us one variable causes another. In other words, you cannot infer causation from descriptive research. So let me give you an example. A researcher in a small Midwestern town discovered that as crime increases, ice cream consumption also increases. So can you say in this study that crime is caused by people eating more ice cream? No, you can't. This is a correlational study, and it's possible that there are other variables that are impacting the increase in crime. And so in this study, what the researchers did was they dug into it a little deeper, and they found that, well, people eat more ice cream during the summer. And during the summer, the days are longer. It stays light until 9 o'clock in most places in this country. People are outside then later at night, so there's more opportunity for crime. Also, people leave their windows open, and that also tends to invite crime in more urban areas. So just because two variables are related to one another doesn't mean one causes the other. Let's look at naturalistic observation, the first type of descriptive research. This is the systematic observation and recording of behaviors as they occur in their natural settings. So there are several advantages to naturalistic observation. One is that it allows researchers to study human behaviors that cannot ethically be manipulated in an experiment. For example, if you'd like to study post-traumatic stress after a significant natural disaster, you can't ethically subject people to a natural disaster. Okay, so this is a benefit of naturalistic observation. It's used wherever patterns of behavior can be openly observed. Negatives or limits with naturalistic observation is that you cannot control variables. So if I'm studying play behavior, for example, of preschool children, and it's going to be the second semester, and I need to write a paper on it for my child development class, and my paper's due on February 11th. So I go to the park on February 2nd, and it's a freezing cold day. There might only be 2 children at the park. So that's going to be a variable that I can't control, and children probably would play for a shorter period of time and most likely very differently than on a beautiful day in the middle of July. So I'm going to stop the first part of the presentation here, take a minute to review your notes, and then we'll pick up on more types of descriptive research next time.